Hello, I'm Jacob Young from the University of Otago in New Zealand. And I'm going to be talking about how we can get rich immersive telepresence experience working on a mobile phone in real time. So if you know anything about New Zealand, you know it's pretty isolated. It's really expensive to travel, so it's always a big deal. And so, of course, I've got my mum asking me every 5 minutes what I'm up to. So if I want to show around Japan, say I'm at Kuromon Market, the usual thing would be to call her up on Skype. She'd answer on her phone, and then I would just show her the sights. But the problem with this is that I've got I completely dictate the direction of attention. She's got absolutely no control of where she's looking, so she has no spatial context in the environment, and it's just really hard to immerse herself within that space. What I'd rather do is allow her to control that viewpoint just by moving her mobile phone. She's not very technology savvy, so we want this to be intuitive. Just look around and the environment moves around with you. And then since the device is tracked, we can obviously view that in a mobile HMD as well, so you can fully immerse yourself in that space. So this is something that's been looked at before. So we've got the pedo inserts paper, where the environment you want to share is captured ahead of time, and then you've got a bunch of mobile phones positioned in there, and they live stream their camera views, which are stitched onto the environment. And the poly system from Synchronisation, where you wear a remote control gimbal on your shoulder, and it allows the remote person to fully look around an environment just by physically rotating the mobile phone. So these are good, but the problem with them is that they require additional hardware or some premeditation. So we've got the capturing the environment ahead of time. Sometimes you want to use these experiences spontaneously, or you don't want to carry the hardware around with you. So Anthony Tang looked at how we could do this a wee bit more ubiquitously. So we just use a 360-degree camera, which is more likely to be owned by other people. Or Jörg Müller looked into how we could do these kinds of experiences using only a mobile phone. But of course, the limitation of these devices means there's always going to be compromises. So I wanted to see if these experiences could be replicated on mobile phone, see if it would provide a decent experience. So what I've done is we've got this equirectangular frame buffer, panorama, so that's wrapped into a sphere that both users are located in. And then each can freely look around in the environment just by rotating the mobile phone. So the user in that environment has their camera stream projected into that environment based on where they're looking, and the remote user has full control over where they look. And then to let them interact within the environment, we allow them to just perform hand gestures in front of the camera. So that's just picked up a normal camera stream, segmented, and sent over to the remote user and projected into the environment with the correct spatial context. So since there's inevitably going to be compromises, we wanted to see what degree we need to do this to. So I've looked into 5 different representations of how this environment can be created. Going from left to right, we get more view independence with each, but they also have their own problems, as you'll see. So the first is live video calling. This is pretty much identical to Skype, but with the pointing interface implemented. So as you move your mobile phone around, you still have no control over the environment. You're just stuck looking at whatever the local user wants you to look at. Live spatial video calling adds spatiality to that concept. So now we've got this environment coming into play, and now the local user's camera is projected into the environment based on their current orientation, and then the local user can look around wherever they want. So this already gives us more spatial context than what something like Skype would give us, but of course there's nothing to see outside of the local user's field of view. To bring context in, we have incremental panoramic calling. So while the local user is looking around and having their camera streams projected into the environment, it's being recorded there, and over time that's going to create a panorama of the surroundings, so the local user can freely visit previously visited areas, which gives static context along with the live focus inside of the local user's field of view. But of course, you're stuck looking at wherever the local user's already been before. If you want to have full control over where you want to look, then you need to capture the whole panorama ahead of time. So panoramic calling with live inserts does exactly that. You capture the panorama beforehand using either a 360-degree camera or using a stitching algorithm. And then the live user's, the local user's current camera frame is projected into that environment to give live context, live focus, sorry. But of course, all of that context is static, so if we want to take that any further, we unfortunately require additional hardware. So what we do is we take a 360-degree camera, connect it to our mobile phone using a USB cable, as you can see on the right. So that can be either on a tripod or you could wear it around your neck or something. We use the Ricoh Theta, but you could use whatever you want in theory. So only problem with this is that the interface to it over USB only provides really low resolution images. So you got 1280 by 720 for the whole environment. Whereas in the other modes, we've got 1280 by 720 just for that small context area. And of course, so when it's projected onto the whole environment, it's quite low resolution. And we've got these really obvious seams here where the two images you saw before meet. But this does provide full live environment. So wherever the remote user looks, they're going to see movement, even if it's outside the local user's current field of view. Unfortunately, I don't really have time to talk about all the implementation details. It gets a bit into depth in the paper if you're interested. But I'll give you a brief high-level overview. So we've got the local user in their environment, that, in the environment they want to share with that remote user. So they capture it either using their mobile phone or the Ricoh Theta. And this is streamed to a remote user who can view the experience either on their mobile phone or in a mobile HMD. So they're connected using WebRTC, which is just a video conferencing API. So we share audio between the two, so they can talk like they normally would. Share video between the two, so that's the unaltered video streams from the local user to the remote, and the remote user sends back their segmented hand images. And of course, we have tracking data exchanged as well, so that the images can be positioned correctly inside the environment. So the audio and video streams are, that's interesting. Sorry about that. So audio and video streams are automatically synchronized for us, which is nice, but what's more important is the video and tracking data, because we need these frames to be correctly positioned inside the environment. We don't want old tracking data to accidentally position frames incorrectly. So we've got an image there on the left and the tracking data on the right, and we need to synchronize these somehow. So we embed a 2-byte identification tag in that data packet. Look at the top left corner of our image, get to 8x8 regions of pixels. These are removed and stored in the data packet alongside the tracking data, and these identification tags are put in the pixels that were removed. Quite a bit of redundancy there so that they're not altered by video compression. So since this is all user-focused, it of course needs to perform in real time so that everyone doesn't get frustrated and give up on it. So we did a quite in-depth performance analysis. It gets into quite a bit of detail in the paper if you're interested, but we do maintain real-time frame rates in all cases. So in live video calling, live spatial video calling, and panoramic calling with live inserts, we've got a stable 60 frames per second for both the local and remote user. And in incremental panoramic calling and live panoramic video calling, we it's a wee bit lower, but it's still acceptable, just because there's additional processing required to update the environment every frame. We also looked into latency. It looks a bit high there, nearly 400 milliseconds in the worst case, but you'll notice that pretty much all of it's unavoidable because it's all camera network latency. We lose over half of it to the camera, so this is just about as good as we can get, really. So we also tested this on users to see how they'd react to using such a system and to see what effects it induced in them. So we ran 2 different user studies, the first of which all the video that the users saw was pre-recorded, but it was streamed over and played in the system, so they could still look around and view it as if the video was arriving live over a network connection, just so we could fully control the conditions. And then it was repeated live with a proper live local user, just to see if any effects we found held. So, yeah, only 26 participants all up, which is quite limited, so we limited ourselves to 3 conditions for now. So just live spatial video calling, incremental panoramic calling, and live panoramic video calling. So the real relationship between these 3 is the amount of spatial context they provide. So, of course, on the left there we've got no context at all, just spatially mapped images, and on the right we've got full 360-degree live context. So we evaluated spatial presence. I've got the significant differences marked with the asterisk there. So you can see that both the modes with the spatial context provided significantly more spatial presence than the mode without it. But there was no significant difference between the two. So what this suggests, to take it with a bit of grain of salt because of the low participant number, but there's no real benefit over having the live context, so we can get a similar experience with just a mobile phone without requiring that extra 360 camera. We also evaluated co-presence, so saw a similar effect, but this time we really need that live presence to get a significant increase. So we also got some qualitative feedback from our users. And this really mirrored the findings from our quantitative results. So all of them felt really spatially present in the environment, even with the limitations of the devices. They really felt that the context contributed to the sense of presence. You know, being able to look outside the blue square that indicates the local user's field of view. They didn't really see a benefit in live panoramic video calling due to the low resolution of the camera used, but that's going to hold for all cameras because we're limited by bandwidth. It's always better to show video in one small spot than spread over a whole sphere. And they really felt engaged with the being able to gesture using their own hands. They seem to really like that feature. So what have I shown? So really these live experiences that you've seen in other papers can be adapted to work on a mobile phone, so they're available for everyone. And they really can be run in real time despite these the limitations. But unfortunately, it's still a real engineering challenge. It's much clearer in the paper. There's a lot of moving parts. It was very painful. And yeah, so this spatial context really does benefit communication and doesn't necessarily have to be live. So you can use only a mobile phone and still get a very immersive experience. Thank you very much.
Can you step up to the mic if you have questions? You guys are doing that. I'm going to see if you have anything on the Slack channel. I see nothing on the Slack channel. There's no one on the mic, so I will ask the question. I guess I'll use this mic to do it. So this seems like a very nice comparison of conditions that were sufficiently close that you could actually get something out of it. But while these look like nice first experiments, the people in them didn't have any real motivation to use the system. They're being paid, I think, $20, and it's an environment that maybe isn't all that interesting to them. Have you thought about a study in which they really would want to be able to go and see what was happening at the other side? Because maybe something interesting is happening that they might not be able to capture and understand well from the small field of view of just the phone by itself.
Yeah, we have looked into that. So we actually tested the connection internationally just over Wi-Fi, and it works pretty well. So we are currently looking to a study run between maybe New Zealand and Germany. So that would be much more interesting for people, obviously. Yeah, probably motivate things a bit more than just looking at the campus. Yeah.
Maybe even something at an event where someone really wants to find out remotely what's happening over there, a parade,